There hasn't been a big earthquake on the southern San Andreas Fault for a long time, and we may have found a reason why.
Recently, NASA has issued a stark warning about the San Andreas Fault, a major tectonic boundary in California. Spanning approximately 1,200 kilometers, this fault line marks the boundary between the Pacific Plate and the North American Plate. Known for its significant earthquake activity, the San Andreas Fault has segments with varying degrees of earthquake risk. NASA's latest findings suggest that the fault is on the brink of a significant eruption, raising concerns about potential devastating impacts. In today's episode, we'll explore the details of this alarming development and what it could mean for the affected regions. The San Andreas Fault runs from the northern part of the state near Eureka at the Mendocino Triple Junction to the southern part near Bombay Beach at the Salton Sea. In the north, the fault meets the Mendocino Triple Junction where three tectonic plates come together. The Cascadia subduction zone also intersects the fault here. Some scientists think a big earthquake in the Cascadia subduction zone could trigger an earthquake along the San Andreas Fault. In the south, the fault ends near Bombay Beach in the Salton Sea. This area is known as the Salton Trough, where the plate boundary is changing from right lateral to divergent. The Colorado River has deposited sediment in this trough, preventing seawater from the Gulf of California from filling it. The fault was discovered in 1895 by Professor Andrew Lawson from UC Berkeley. After the 1906 San Francisco earthquake, Lawson mapped out the surface ruptures. He found that the locations of these ruptures made up a nearly perfect line along the fault. He then concluded that the San Andreas Fault was the origin of the earthquake. This line passed through the San Andreas Lake, a depression formed by the fault where water had settled. Many people think Lawson named the fault after this lake. However, Lawson actually named it after the surrounding San Andreas Valley. In 1953, geologist Thomas Dibley found that hundreds of miles of lateral movement could happen along the fault. A project called the San Andreas Fault Observatory at Depth, or SAFOD, was conducted near Parkfield, California from 2004 to 2007. Scientists drilled through the fault to collect core samples and make observations to better understand the fault's behavior. The fault is divided into segments. The northern segment runs from Hollister through the Santa Cruz Mountains up the San Francisco Peninsula, offshore at Daly City, and back onshore at Bolinas Lagoon. It then goes through Tamales Bay and Fort Ross and back offshore at Point Arena, ending at the Mendocino Triple Junction. The central segment runs from Parkfield to Hollister, and this segment shows a seismic creep, meaning the fault slips without causing earthquakes. The southern segment of the San Andreas Fault, known as the Mojave segment, begins near Bombay Beach, California. In this area, Box Canyon near the Salton Sea shows upturned strata connected to this section at the fault. From there, the fault runs along the southern base of the San Bernardino Mountains. It then crosses the Cajon Pass and continues northwest along the northern base of the San Gabriel Mountains. These mountains are created by the movement of the San Andreas Fault and are often called the Transverse Range. In Palmdale, you can easily see a part of the fault at a road cut out for the Antelope Valley Freeway. The fault continues northwest alongside the Elizabeth Lake Road to the town of Elizabeth Lake. As it goes through the towns of Gorman, Tejon Pass, and Frazier Park, the fault starts to bend northward, forming the Big Bend. This bend is thought to be a place where the fault locks up in Southern California. Earthquakes in this area happen roughly every 140 to 160 years. Northwest of Frazier Park, the fault runs through the Carrizo Plain. This is a long, treeless plain where the fault is clearly visible. The Elkhorn Scarp makes the fault trace along much of its length in this plain. This southern segment, stretching from Parkfield to Monterey County to the Salton Sea, is capable of producing an 8.1 magnitude earthquake. At its closest, this fault passes about 35 miles northeast of Los Angeles. A large earthquake in this area could kill thousands of people in LA, San Bernardino, Riverside, and nearby areas. It could also cause hundreds of billions of dollars in damage. The Pacific Plate lies to the west of the fault and moves northwest. Meanwhile, the North American Plate to the east moves southwest. The slippage rate averages about 33 to 37 millimeters a year across California. The southwestward motion of the North American Plate creates compressional forces along the eastern side of the fault, forming the Coast Ranges. The northwest movement of the Pacific Plate also creates significant compressional forces, especially where the North American Plate forces the San Andreas to jog westward. This has led to the formation of the transverse ranges in Southern California and to a lesser extent the Santa Cruz Mountains. The main southern section of the fault has existed for about 5 million years. The first known form of this section was the Clemens, well, Fenner, San Francisco fault zone around 22 to 13 million years ago. The San Gabriel Fault then became a major site of movement between 10 to 5 million years ago. It is believed that the modern San Andreas will eventually transfer its motion to a fault within the eastern California shear zone, and this complicated evolution is mainly due to the Big Bend and differences in motion between the plates and the trend of the fault and its branches. The San Andreas Fault was first identified in Northern California by Andrew Lawson, a UC Berkeley geology professor, in 1895, and again it was named after the San Andreas Valley. 11 years later, Lawson found that the fault had extended into Southern California after studying the 1906 San Francisco earthquake. In 1903, geologists Mason Hill and Thomas Dibley proposed that the fault had large-scale lateral movement, an idea that modern plate tectonics later confirmed. Seismologists have found that the San Andreas Fault near Parkfield in central California consistently produces magnitude 6.0 earthquakes about every 22 years. Notable earthquakes occurred in 1857, 1881, 1901, 1922, 1934, 1966, and 2004. Due to this regular activity, Parkfield is a key area for earthquake research. In 2004, scientists began work on the San Andreas Fault Observatory at depth just north of Parkfield. The project involves drilling a hole nearly 3 kilometers into the Earth's crust and into the fault. Sensors placed in this hole will record nearby earthquakes. A 2003 study discovered a link between the water level in Lake Cahuilla, now the Salton Sea, and seismic activity along the southern San Andreas Fault. High water levels in the lake can more than double the stress on the fault, triggering earthquakes. This finding may explain the long period without a major earthquake in the region since the lake has dried up. Over the last 23 years, the San Andreas Fault system has been extensively studied, leading to about 3,400 scientific publications. These studies have greatly advanced our understanding of this significant geological feature. A study published in 2006 in the journal Nature by Yuri Fialko found that the San Andreas Fault has reached a stress level high enough for an earthquake greater than 7.0 in magnitude. Fialko, an associate professor at the Scripps Institution of Oceanography, noted that the risk of a large earthquake is growing faster than previously thought. The study indicated that the southern section of the fault, particularly near Los Angeles, is most at risk. The central section experienced a major earthquake in 1857, and the northern section had one in 1906. However, the southern section has not had a significant rupture for at least 300 years. A major earthquake on the southern San Andreas Fault would cause severe damage in the Palm Springs, Indio metropolitan area, and other cities in San Bernardino, Riverside, and Imperial counties. It would also affect the Mexicali municipality in Baja California. Reports from the U.S. Geological Survey have varied in their predictions of future seismic events. Accurate prediction of major earthquakes remains challenging. The most recent USGS forecast, called UCERF3, released in 2013, estimated that an earthquake of magnitude 6.7 or greater occurs about once every 6.7 years statewide. The report also suggested a 7% chance of an earthquake of magnitude 8 or greater occurring along the San Andreas Fault in the next 30 years. Another USGS study in 2008 examined the potential consequences of a major earthquake in Southern California. It predicted that a magnitude 7.8 earthquake on the southern San Andreas Fault could cause around 1,800 deaths and $213 billion in damage. In 2008, a paper studied past earthquakes along the Pacific coastal zone and found a correlation between seismic events on the northern San Andreas Fault and the southern part of the Cascadia subduction zone. This zone stretches from Vancouver Island to Northern California. Hey, if you enjoyed today's video, then don't forget to give it a like and make sure you smash the subscribe button for more informative content. And until then, keep exploring.